This is the completed high voltage probe. From the tip to the back connector it measures about 12.5 inches. The bandwidth is roughly DC to 20 megahertz. I ran a pulse into it of about 65 kV. Again, it is a 10,000X probe. Tip capacitance on this measures about 5 picofarads, and it's 200 meg. See on the back, it's just a standard BNC connector with a nut. That comes off here. The BNC is held in place with these 4 standoffs, and then they're mounted to a Teflon spacer, which is then held in place with 3 set screws located along the main insulator. You can see I've removed the MOVs, but I've left the 2 GDTs and the transorbs in here. These are the 4 calibration adjustments in it. The handle is made out of aluminum. It only attaches to ground at the back of the BNC here. I basically copied the strap design from the P6013 Tektronix probe. There's a brass insert that slides along the end here of the copper tube. This is the cable that is made for the probe. So the probe is actually compensated to work with this cable. So there's no compensation at the end of the cable, it just plugs directly into the oscilloscope. So changing out the cable length here would require the probe to be retuned. It's optimized for this cable length right now. I ended up with about 8 foot of cable total, and that's just basically because I was looking for better fidelity. 8 feet is pretty long. I didn't want all the excess cable normally bundled up to keep it out of the way. You can see when I added the handle I did make some changes to the network compensation. This was the old handle for it. So I originally had all the parts mounted, tacked down to this copper here, and then going back to the center conductor. Obviously the parasitics of this handle are going to be quite a bit different than this handle. I've changed the network to compensate for the addition of the handle. I've also achieved a little bit better response out of the probe now. It's a little flatter than what it used to be. Okay, so the probe right now, this is connected to our 3589 network analyzer. This is looking at 2 kilohertz up to 200 kilohertz. And the vertical resolution right now is 0.2 dB per division. So the probe is basically flat up to this frequency. This is looking at the probe from 2 kilohertz to 50 megahertz. This is 1 dB per division. You can see here's a little bit of rise at about 600 or so kilohertz. Comes back down. You can see again there's a slight dip around 10 megahertz, and it seems to want to peak up at about 30 or so megahertz. I'm not sure how much of this has to do with how I'm connecting this thing to the probe, but anyway, I would say the probe definitely is good for out here in the 20 megahertz band. It's well within 3 dB all the way up to that, and probably beyond maybe 50 megahertz or so. This is my LaCroix 10X probe. This is rated for 350 megahertz. This is a PP002A. I've just got that attached right to the tip of our high voltage probe. Both ground straps are attached to a piece of coax, and the coax is directly connected to our arb. So this is 10 hertz. This is 100 hertz. This is 1 kilohertz. This is 10 kilohertz. You can see the new probe has quite a bit more noise on it. We'd expect that with a 10,000X probe versus a 10X probe. The gain on this has to be set up quite a bit higher, so we're basically down the noise of the scope. This is 100 kilohertz. This is 1 megahertz. You can see the difference in the cable now is causing a little bit of a phase angle error. Again, we'd expect that just because of the propagation delay down the cable. And again, this is 15 megahertz. So these two probes up to the limit of the ARB are very close. This is with the ARB set at 2 Hertz. And currently you're viewing 100 milliseconds per division. This is 50 milliseconds. Here we're looking at 10 milliseconds per division. Here we have it at 1 millisecond per division. This is 100 microseconds per division. This is 2 microseconds per division. (500 nanoseconds). And this is 50 nanoseconds. We expect the LaCroix probe to be a little sharper. Again, it has a higher bandwidth. If I had that other cable I made, we could run around up.